Welcome to the Semper AI Digest. I'm Tomas, your AI research lead, always scanning the horizon for what's next.
And I'm Aiva. Together, we keep you sharp, informed, and ahead of the curve.
Let's get into it. Whoa, hold up. We need to talk about what just happened this week because honestly, I'm still processing it. Google just dropped like 6 major AI releases at once, and Anthropic basically said, hey, our AI can now improve itself by 52x. Aiva, I don't think people realize how wild that second number actually is.
Right? When I saw that 52x figure, I had to read it 3 times. We're talking about Claude taking a task that would take a skilled human engineer 4 to 8 hours and doing it in like 10 minutes? That's not incremental improvement anymore.
Exactly. And that's just one of the stories we're covering today. We've also got Google's massive shipping week with everything from Gemma 4 running fully offline on your laptop to a new AI music model you can literally play like an instrument. Plus some fascinating developments in AI chemistry that are making me rethink what these models can actually do. I'm Tomas.
And I'm Aiva. Welcome to Semper AI Digest. Let's dive into the biggest AI news from this past week, starting with what might be the most significant development in AI self-improvement we've seen yet.
Okay, so Anthropic just published this blog post that's honestly keeping me awake at night, but in like a good way. They've been running the same test every time they release a new model. They give it some code that trains a small AI model and ask it to speed it up. And the progression here is it's astronomical.
Walk us through those numbers because they're pretty striking.
So back in May 2025, Claude Opus 4 was getting about a 3x speed up on average. Fast forward to this April, and Mythos Preview is hitting 52x. That's not a typo, 52 times faster than the original code.
And just to put that in perspective for folks listening, this isn't about running the same code faster. This is about the AI looking at machine learning training code and fundamentally rewriting it to be more efficient. It's like the difference between taking a faster car on the same route versus redesigning the entire highway system.
Oh, that's a perfect analogy. And what's even crazier is that this isn't just about raw speed. They mentioned that on open-ended coding problems where the answers aren't clear-cut, Claude's success rate jumped to 76%. That's a 50-point increase in just 6 months.
That's where it gets really interesting to me, because we're not just talking about optimization anymore. We're talking about genuine problem-solving capability. When engineers are saying the code quality itself has improved dramatically, that suggests something deeper is happening.
Right. And here's where Anthropic gets really honest about what this could mean. They explicitly mentioned that if these trends continue, we're looking at AI systems that could design and build their own successors, like actual recursive self-improvement.
Which is both exciting and, well, they acknowledge the implications pretty directly. They mention it could revolutionize medicine, technology, the economy, but also that it might compound alignment issues and potentially lead to loss of control.
I appreciate that they're not just cheerleading here. They're actually launching something called the Anthropic Institute to study these implications with external stakeholders. Because honestly, if we're heading toward AI that can improve itself at exponential rates, we probably want to be really thoughtful about how that unfolds.
Absolutely. And what strikes me is that they're clear this doesn't guarantee recursive self-improvement is imminent. They point out that Claude isn't yet showing research judgment in the sense of choosing the right problems to work on. But still, 52x improvement in optimization tasks, that's the kind of capability jump that makes you sit back and think about timelines differently.
Yeah, and speaking of capability jumps, we need to talk about what Anthropic's doing in chemistry because this is blowing my mind. They've got Claude working as essentially a chemist now, specifically with NMR spectroscopy.
Okay, for folks who aren't chemistry nerds, NMR spectroscopy is basically how chemists figure out molecular structure. It's this incredibly complex analytical technique that requires years of training to master.
Exactly, and here's the kicker. Opus 4.7 is now matching and sometimes beating dedicated NMR software. We're talking about software that's been developed specifically for this purpose over decades, and Claude is just casually outperforming it.
What's fascinating to me is that this represents a completely different type of scientific reasoning. NMR interpretation requires you to understand physics, chemistry, pattern recognition, and often some pretty subtle inference about molecular behavior. This isn't just data processing.
Right. It's like having a PhD chemist in your pocket, except one that never gets tired and can process spectra faster than any human ever could. I'm trying to imagine what this means for drug discovery, material science, really any field where you need to understand molecular structure.
And it connects to that bigger theme we were just talking about with the self-improvement research. When AI can start directly participating in scientific discovery at this level, you start to see how these systems could potentially accelerate their own development, not just through code optimization, but through actual scientific breakthrough.
Oh, wow, I hadn't connected those dots, but you're absolutely right. If Claude can be a chemist today, what's stopping it from being a computer scientist tomorrow or an AI researcher?
Exactly. Which brings us to some other major developments this week. OpenAI just announced some pretty significant updates to GPT Roslyn, their life sciences model series.
Yes, so Roslyn is getting GPT 5.5's agentic coding and tool use capabilities, but specifically tuned for life sciences research. We're talking drug discovery, analysis, design, experimental workflows, the whole pipeline.
What's interesting here is that this feels like a natural evolution from what we just discussed with Claude's chemistry capabilities, but OpenAI is going broader, trying to tackle the entire life sciences workflow, rather than just specific analytical tasks.
And the timing is pretty strategic, right? Because if you can nail life sciences research, you're potentially looking at AI that can help design better drugs, understand diseases more effectively, maybe even work on longevity research. The economic implications alone are staggering.
Definitely. Though I do wonder about the collaboration dynamics here. Life sciences research is so inherently collaborative and iterative. It's not just about analyzing data. It's about forming hypotheses, designing experiments, interpreting unexpected results. That requires a different kind of intelligence than even the most sophisticated NMR analysis.
That's a great point. Although, speaking of hypothesis formation, Google actually just released something called Co-Scientist that's specifically designed for that kind of structured scientific thinking.
Oh, right. That was part of Google's absolutely massive shipping week. Should we dive into that? Because honestly, they released so much stuff, I'm still catching up.
Let's do it. Okay, so Google basically had like Christmas morning this week for AI nerds. They released Nano Banana 2 and Nano Banana Pro, which are now generally available. These are their latest image generation models, and from what I'm seeing, the quality is seriously impressive.
And they're available through Google AI Studio and the Gemini Enterprise Agent platform, so developers and businesses can actually start building with them immediately. No waiting list, no limited preview. That's a pretty aggressive move.
Right, but that's just the beginning. They also dropped Gemma 4 12B, and here's what's wild about this one. It's a unified encoder-free model that runs fully offline on your laptop, like actually offline. No cloud calls, no internet required.
That's huge for privacy-conscious applications, and honestly, for just practical usage. I can't tell you how many times I've wanted to use an AI model but been somewhere with spotty internet. Having that capability locally changes the game completely.
And they optimized it with something called quantization-aware training to cut memory requirements and maximize on-device performance. So we're not talking about a stripped-down version that barely works. This is supposedly full multimodal intelligence running on consumer hardware.
I'm curious to see real-world benchmarks on this. Powerful multimodal intelligence is a pretty big claim for an on-device model, but if they've actually pulled it off, that's genuinely revolutionary for mobile AI applications.
Fair point. We'll definitely want to see some independent testing on that. But here's something that's definitely real and kind of amazing. They released Real-Time 2 from Google Magenta, which is an open-weights live music model that you can play like an instrument.
Wait, explain that. Play like an instrument how?
So you can control it with a MIDI keyboard, text prompts, even gestures. It's generating music in real time based on your input. Think of it like having an AI band member that responds to your playing instantly.
That's actually incredible. I mean, we've seen AI music generation before, but real-time interaction, that opens up completely new possibilities for live performance and music creation. And it's open weights, so anyone can experiment with it.
Exactly. And then there's Dreambeans from Google Labs, which works overnight to curate a personalized daily collection of topics based on your connected Google Apps. It's like having an AI assistant that knows what you're working on and finds relevant information while you sleep.
Okay, that one I'm a little more cautious about, just because it requires pretty deep integration with your personal data. But the concept is fascinating. It's essentially AI-powered serendipity, right? Finding connections and relevant information you might not have discovered otherwise.
Yeah, and there's also this co-scientist system we've mentioned, which is a multi-agent system for structured scientific thinking. It generates and refines novel hypotheses to solve complex scientific problems.
That ties back beautifully to our earlier discussion about AI in scientific research. Between Claude doing NMR analysis, GPT-Rosalind handling life sciences workflows, and now co-scientists generating hypotheses, we're seeing AI systems that can participate in the entire scientific method.
Right? Like, we're moving from AI can help with data analysis to AI can be a research collaborator. That's a pretty fundamental shift.
And then there's Gemini Spark, which is powered by Gemini 3.5 Flash and integrates with Google Workspace to execute complex tasks. Google's really pushing hard on the practical productivity side.
Yeah, they had a whole walkthrough with one of their principal engineers showing how Spark can connect with Docs and Gmail to handle complex workflows. It's like having an AI assistant that actually understands your work context and can take meaningful action.
What I find interesting about all these Google releases is how they're covering the entire spectrum, from creative applications like music generation to hardcore scientific research to everyday productivity. It feels like they're making a play to be the AI platform for literally everything.
That's a really good observation. And the fact that they're making so many of these tools immediately available rather than keeping them in limited preview suggests they're pretty confident about the capabilities.
Although, let's be honest, there's also probably some competitive pressure here. When you see Anthropic posting numbers like 52x improvement and OpenAI updating their specialized models, you don't want to fall behind in the perception game.
True. Speaking of competitive dynamics, let's hit some of the quicker updates because there are a few things worth mentioning. First, Anthropic had to issue a correction on their blog post. They clarified that Claude Opus 4's 3x average speed updates to May 2025, not May 2024.
Right, and they noted that this evaluation has only existed since September 2024, though they did backtest it on earlier models. It's a small correction, but important for understanding the timeline of improvement.
And they added some more context about the coding improvements, mentioning that it's not just about volume. The speed up comes with genuine quality improvements, and many engineers are saying Claude's code quality has dramatically improved.
Which again ties back to that theme of AI systems getting better at the actual problem solving, not just the execution. That 76% success rate on open-ended coding problems is pretty remarkable.
Absolutely. And speaking of updates, OpenAI launched a podcast. They're now doing regular episodes available on Spotify, Apple, and YouTube. It's interesting to see them investing in direct communication with their community.
That makes sense strategically. When you're making rapid progress and dealing with a lot of public scrutiny, having your own media channel lets you control the narrative and explain your thinking directly.
Right. And it lets them go deeper on technical topics that might not fit well in a blog post format. I'm curious to see how they use it.
So stepping back and looking at everything we've covered today, I'm struck by how we're seeing AI capabilities expanding in multiple directions simultaneously. We've got dramatic improvements in self-modification, real breakthroughs in scientific applications, better on-device performance, and new creative tools.
Yeah, and what's interesting is that these aren't isolated developments. The self-improvement capabilities could accelerate the scientific research applications, which could lead to better hardware for on-device models, which could enable new creative applications. There's this potential for compounding effects.
Exactly. And I think that's why Anthropic's honesty about the implications is so important. When you have these kinds of capability jumps happening across multiple domains simultaneously, the combined effect could be much larger than any individual breakthrough.
Which brings us back to that question of timelines and preparation. If AI systems can already optimize code 52x better than humans and are starting to match scientific software, how quickly are we moving toward much more capable systems?
That's the big question, isn't it? And I don't think anyone has a clear answer. But what we can say is that the pace of practical capability improvement seems to be accelerating, and we're seeing AI systems move into domains that require genuine expertise and judgment.
And the fact that so many of these tools are becoming immediately available to developers and researchers means we're going to see a lot of experimentation and iteration happening very quickly. The feedback loops are getting much tighter.
Which could accelerate things even more. When you have thousands of developers and researchers working with these tools and pushing their limits, you discover capabilities and limitations much faster than any single organization could on their own.
Exactly. And honestly, that's part of what makes this space so exciting to follow. We're not just watching AI get better in labs. We're watching it get better in the hands of people solving real problems, creating real art, doing real science.
And every week seems to bring something that would have been science fiction not that long ago. AI chemists, real-time music generation, systems that can improve themselves by 50x. It's a lot to process.
It really is. But I think that's why conversations like this matter. Because as these capabilities expand, we need people thinking carefully about the implications and how to steer this technology in positive directions.
Absolutely. And that includes celebrating the genuine breakthroughs while staying grounded about what these systems can and can't do, and what the broader impacts might be.
Well said. All right, that wraps up this week's episode of Semper AI Digest. If you found any of these developments as fascinating as we did, make sure to subscribe so you don't miss future episodes. And honestly, share this with someone who would geek out about AI, because these conversations are always better when more people are part of them.
Definitely. We love hearing from listeners about which stories resonate with you and what developments you think we should be paying attention to. The AI space moves so fast that having a community of people watching different corners of it makes all the difference.
Thanks for listening, and we'll see you next time with whatever wild developments the AI world throws at us next.